In this video, we will now discuss inside the physical optics, the reflection and refraction of light. They are from the word reflect and refract. So what's the difference between them? We will have to discuss it. Now when light comes from some source and it hits the surface, then what will happen to that light? And we say that if, for example, we are having a surface like this and light comes in, then this light will reflect. This is one way, this is one possibility that this light will reflect. Similarly, if another ray of light is coming in, then this light ray will reflect as well. And similarly, if a third ray of light is coming, and it will do the same. Now, such kind of reflection which we are having this surface is a very polished or smooth surface. Then we will have the reflection like this, which we call the specular reflection. And if the surface will be not very smooth or polished like a mirror or glass, then if the surface is somehow rough surface, then what will happen that on each segment here we will have the specular reflection. For example, this light ray is coming in and it is hitting this portion, so here the light will go this way. And if it comes in and this hits, for example, this segment, then from here it will go this way. And if it comes here and hits another way or another page here of this rough surface, then it may go like this. So here the lines or the wavefronts which were coming in, they were in one line, while this reflection which is occurring is not like this one, and we call such a reflection is diffused reflection. As most of our surfaces are rough, they are not glass or very polished surfaces always like metal. So we are having, in most of the cases, we are having diffused reflectance. Now, if we are having water and water is very still, then we may have specular reflection, but normally the water is also not very still, and due to the air which is flowing on the surface of water, and we are having a diffused reflectance. So we will not consider the diffused reflectance, but we will only talk about the specular reflection, for which we will develop some mathematics as well. And now, in order to go on for the mathematics, let's say we are having a surface, and this surface is like a boundary of any material, and the surface is like this. So this is the surface, and on this surface we will have now to consider our reflections. So the very first thing that I will have to draw a perpendicular line to this surface. So the surface is somehow, let's say, up to, this is a material, and this material thickness is equal to this much. Now this perpendicular line, we will develop some mathematics here. So let's say we are having a ray of light, and I will consider only one ray, and this ray of light is coming in and hitting this surface. So the one chance that will be that this ray of light will reflect exactly at the same angle with which it has struck this. So this angle I call, means with this perpendicular line, this angle is in this direction. So this angle I call the incidence angle, theta I, because this is the incident light. And this angle which it makes with this I call is theta R, because this is the reflected light and this is the reflected angle. So with this perpendicular we will have to calculate this angle, and there is a possibility that some of the light will, means if I go on in this direction, then this will be the straight direction in which this light was supposed to go. But we observe that when another medium, let's say this medium we are having is air, and let's say this medium is a glass, or let's say water. So from here, from air, the light ray comes in, and this light ray was supposed to go in a straight line, but this doesn't happen, and this light ray actually bends. And this bending of light, when it transmits, this bending of light we call refraction. This refracts, this bends this light, so we call, from refract word we call this is refraction. And now the angle of it which it makes with this perpendicular line is called theta t. Theta t means the angle of transmission, because this ray is bounced back here and some of its portion has gone into this material, and then if for example we are having after this the air, then in this air it will continue as it was in this direction. So this angle will again be the same here. So we will not go there, but we will discuss only this portion, that this is the transmitted angle and this transmission is actually called the refraction. And here let's say that I call this is medium 1 and this is medium 2. Now over here the same is true. If the light is going from this direction, then this will be the incident, and exactly on the same line the reverse is possible as well, that this is the incident, then this is the perpendicular line, and this will go away from this perpendicular line. Like for example, this is the actual line and it goes away from that line. It is true that the reverse is possible as well. And now here the very important thing is actually a quantity that we will have to define, and that is the index of refraction. The index of refraction is important here, because this light ray is reflecting. Then what is the index of that refraction? It depends on the two media here. Now when we consider light, then we know that we know that light travels at a constant speed, and that speed is equal c equals 2.99 and 10 raised to the power 8 meter in 1 second. This speed is actually in free space, or which we call vacuum. Now, when any other medium is encountered, then this speed lowers. And how much it lowers, it will give us the idea of the index of refraction. So I can write that the index of refraction is actually the ratio of the speed of light, in free space to the speed of light, in a medium, any other medium except free space. So now, if this medium is also a free space, then it will cancel and we will get that n is equal to 1. So, for free space, our index of refraction is 1, and I can write here this by c and this by v. So, c is the speed of light in vacuum, while v is the speed of light in any other medium. So if v is equal to c, then we will have the index of refraction equal to 1. Index of refraction is a ratio, and it gives us the idea that how light is slowed down inside a medium. Now I can write this that n is equal to c over v. Now we know for any other medium, this v will always be less than c. So when this is less than c, then it means that this n will always be greater than 1. Because when this one will get lower than this, then the ratio will get greater than 1. So the n values are actually, I can write that the n values, this can be equal or less than c. So here the n value will be greater or equal to 1. When n is equal to 1, we will have vacuum. When n will be greater than 1, we will have the other media. And that is that if, for example, I consider air, so for air the n value is 1.003 probably, 1.003. So it is slightly greater than 1. So air can be considered close to vacuum. If I write this for this is the n for air, and the n for glass is approximately from, we are having a variety of glasses, so it starts from 1.5 and it ranges to 2. Similarly, the n for water is equal to 1.33. So this gives us the idea that the speed of light lowers more in glass compared to water or compared to air. And the maximum index of refraction we are having for the diamond. This is for the diamond, we are having this equal to 2.417. So in diamond, we experience a very, very slow speed of light.